Hey everyone, welcome back. Today we're going to be looking at polynomials. So if you're playing along with the Hazy 11 Methods textbook, we are now looking at chapter 4. So to start with, we're just going to take it back and actually define what a polynomial is. All right, so a polynomial is a function of the form p of x, so p for our polynomial, and it's equal to this whole thing here. So we've got our highest power n with our coefficient a subscript n. And then what we're doing, we're adding the coefficient of n take 1 times by x to the power n take 1. And that will keep taking 1 away from our power and our subscript until we get all the way to our constant term a naught. All right. So you can see that we've got a subscript 2 times x squared plus a subscript 1 x to the 1. You can see that that subscript has dropped 1, that power has dropped 1. And that, as I said, continues all the way until we're left with just our constant term. All right, and a naught, a1, all the way up to an are constants or numbers, so they're not going to be variables. A few little pieces of terminology that I'm going to be using throughout this little chapter. I just want you guys to be exposed to them, have a bit of a look at those. So x is the variable, so might not be x in all cases. Most of the time it will be x, okay? So x is our variable. A naught is our constant term, so it's our number without a variable attached to it. An is the leading coefficient, all right? So an is the coefficient that is attached to x to the highest power, and an will always be non-zero, okay? Any other ar is the coefficient of the variable term to that r power, and this is for any r1 up to n, all right? And r is an integer. Okay, so a subscript of 1, so when r equals 1, that coefficient will be attached to the x term, x to the power 1 term, all right? And then n is the degree of the polynomial, which is also our highest power. All right, so I'm just going to do a quick example of how to actually classify polynomials, okay? So we've got our polynomial here, p of x equals 5x to the power 4, plus 7x squared, take 3x plus 7. So this polynomial is has degree 4, because our highest power is 4, okay, our largest n. It has a leading coefficient of 5, so that's the coefficient that's attached to our x term with the highest power. The coefficient of x, so we go and we look at x, the coefficient is -3. So this sign here always is with our coefficient number. And then our constant term is 7, so it's the term here that doesn't involve x to any power, all right? And that's just sort of a base classification of a polynomial. So polynomials of a small degree have special names. So we've been dealing with a couple over the last little while, and one of them for a couple of years now, okay? So if we're looking at polynomials of degree 1, we're actually looking at a linear equation. Now, it might not look like a typical linear equation that you're used to. We might be used to y equals mx plus c, but please know that this is exactly the same as that, okay? A polynomial of degree 2 is a quadratic, so the chapter we just finished was dealing with quadratics, and it is in the form p of x equals ax squared plus bx plus c, and has degree 2. When a polynomial has degree 3 and is p of x equals ax cubed plus bx squared plus cx plus d, we call this a cubic, okay? We'll be dealing with those a fair bit in this chapter as well. And then finally, the last polynomial we actually give a name to is a polynomial of degree 4, and we call that a quartic, okay? And quartics will look something along these lines. And hopefully you have noticed that every single polynomial, that leading coefficient it's a in every single one, but a cannot equal 0, all right? If a is equal to 0, then that polynomial will not be a quartic, for example. So if a in this quartic here is 0, then we've actually only got a cubic, okay? So a, that leading coefficient, cannot equal 0. So I want to go through polynomial equality, all right? So we can use these coefficients if we're told that two polynomials are equal and one polynomial has a bunch of unknowns. We can actually equate the coefficients to find those unknowns. So two polynomials are equal if and only if they have the same degree, so same highest value of n, and the same corresponding terms have equal coefficients. Okay, so as I said just before, if we are told two polynomials are equal, we can equate coefficients to find unknowns. So an example of this, find a, b, and c given that 12x cubed plus 15x squared take 46x plus 21 equals 4x take 3 multiplied by ax squared plus bx plus c for all x. So this little symbol here just means for all. All right, so this is supposedly true for all x. Let's find a, b, and c. What I'm going to do first, I'm going to expand that right-hand side, okay? It's going to get a little bit messy, but that left-hand side hasn't changed at all. You can double check that by just eyeballing that. All I've done is multiply this first term in the first bracket by every term in the second, and then the second term into that second bracket as well. So we end up with 4ax cubed plus 4bx squared plus 4cx. Take away 3ax squared, take 3bx, take 3c. All I'm going to do is collect the like terms. So obviously 4ax cubed is the only x cubed term. There are two x squared terms, so we take the coefficients out the front, just like this. Same thing with our x term, and then 3c, negative 3c, is our only constant term. So now that we have it in the form ax cubed with a coefficient, x squared with a coefficient, x with a coefficient, and our constant term with a coefficient, we can actually equate to the left-hand side. All right, so equating coefficients looks a bit like this. So if we're going to look at our x cubed term, all right, on the left-hand side, our coefficient of x cubed is 12, so we write that on the left-hand side. On the right-hand side, our coefficient of x cubed is 4a, so we can write that on the right-hand side. And if we're going to solve for a, we find that a equals 3, all right? If we're going to look at the x squared term, all right, looking on the left-hand side, our coefficient of x squared is 15. We plonk him there. On the right-hand side, our coefficient of x squared is 4b, take 3a. So that whole coefficient comes to our right-hand side. And you can see that I've actually substituted in the a we found just above into that equation, and we've solved such that b equals 6. Now, x, same thing. On the left-hand side, our coefficient for x is negative 46. On the right-hand side, it's 4c, take 3b. All right, so we put that on the right-hand side there. Now, at this stage, we don't actually have a value for c. But if we then look down one more line, we can see our constant term. So 21 on our left-hand side has to equal negative 3c. So therefore, c equals negative 7. All right. I've then substituted that into our x term and solved for b, and just double checking that they are equal. And then just down here stating our final answer. So a equals 3 as found up here, b equals 6 as found here, and c equals negative 7 as found here. And that is all that question asks you to do. All right. So if you are playing along with the Hazy textbook, have a crack at questions 4A.1. chapter 4.A.1, sorry, Q1 odds, question 2, question 3, and then chapter 4A.2, questions 1 through 4. All right, we'll talk to you guys next time.